Welcome to Balco's AIA Continuing Education series. Today's AIA course is titled Fundamentals of Photoluminescent Egress Systems. This course has been approved for one learning unit for health, safety, and welfare with the American Institute of Architects. Balco is part of the Engineered Building Solutions Group, a segment of CSW Industrials. The EBS Group unites Balco, Metacock, SmokeGuard, and Greco. These four leading brands provide innovative, safety-focused solutions for architects, building owners, engineers, and contractors with a shared commitment to life safety by design. Balco manufactures high-performance architectural construction products for the commercial market, which includes a full line of expansion joints, egress systems, fire-stopping products, and much more. You can view our full line of building products at balcousa.com. Balco is a registered provider with the American Institute of Architects CES program. This course is approved and in compliance with AIA. This program is not intended to promote any specific construction material or method of use. At the completion of this video course, you will need to take our 10-question test and get 70% correct to receive your AIA Certificate of Completion. You will receive your certificate via email. If you are an AIA member and you provided your AIA member number, we will report your course completion to AIA CES records. Please allow for up to 10 business days to report credit to AIA. This presentation is copyrighted by Balco. Any reproduction, distribution, display, or use is prohibited without written permission. By the end of this course, you'll understand the history and purpose of photoluminescence, its importance in building safety, and how it aligns with key building codes. You'll also learn performance standards and how to choose the right photoluminescent materials for specific applications. Today's presentation was recorded by Steve Cooper. Steve is Vice President of Promotions and Training for Balco. Steve works directly with architects, specifiers, and distributors on product education and project specifications. With that, let's turn it over to Steve.
Today we're going to talk about the fundamentals of photoluminescent egress markings. These are typically done in high-rise buildings. A high-rise building is anything with access 75 feet and higher with occupied space. This is a typical, drawing schematic of the plan views of a stair so that you can see where the landings are and where the steps are, and then an elevation view as well so that you can see the height of the structure and the path going out. So there's different types of luminescence. So we're going to be talking about this whole glow-in-the-dark kind of process that has been introduced into the building environment to allow for people to escape through egress stairwells during some kind of an emergency. There's different types of luminescence, so we'll start there. Self-luminescence, which is a radioactive item. So anything that has got its own source that would be mineral-based would be some type of radioactive, and those have been introduced into building signs, but they're mostly being phased out now. They were called tritium signs. That's the exit signs that they put above the doors. That's not really part of this process. Chemiluminescent, which is like the glow sticks like you see at the fair or something like that. There's a two-part or multiple-part mixture. When you crack the little vials open inside by twisting it and shake it, they glow. Or there's bioluminescent, which is just natural plants and animals and things like that. But what we're talking about is going to be photoluminescent charged particles. So it's basically pigments with a rare earth material introduced into it that is not radioactive and it's not bioluminescent. It absorbs energy through light force, and then it introduces that light back out when the charge goes away or when the lights go out, then it glows. Different kinds of materials are used to carry this. You can introduce this kind of photoluminescent material into paint, tapes, into plastics, different kinds of coatings. So we'll talk about what some of those are and what the most effective ones are for use in the egress stairwell markings. Charging just comes from some sort of light source. So it can be sunlight, which is very powerful. UV and all that really charges these particles. In a very short amount of time, you get a whole lot of bright for a long time. That's what I mean by saying that these are very effective. Fluorescent light does well too. Incandescent, halogen, metal halide like the gymnasiums have, where you turn the lights off and it takes a long time for it to come back up. And LED blue light, which is also quite efficient. So all of those items will charge these particles, which will allow the product to glow in the dark when you're trying to find your way out of a structure. So I'll give you a little bit more information, just a little background. This really started out in the marine industry many years ago, where there was some offshore rig fires. It was dark, people couldn't find their way, so they started introducing photoluminescent paints, and then that moved into other parts of industries, just like transportation, like in buses and trains and airplanes and things like that. Some are electrical lighted, some are this kind of glow in the dark material that charges from light. So when the lights go out, you can see the pathway, to make your way to the exits and things of that nature. And finally, in the last, 20, 30 years, it has made its way into the construction and building industry. As it happens, sometimes the catalyst for change and building codes comes from some kind of a building tragedy or disaster that was unforeseen. People didn't realize what they were into until it was already there. And so the MGM Grand Fire is one that's used quite often. And so something that came from that is they realized there were a lot of holes in the structure that they needed to fill in and with some kind of fireproof materials. And then later on, the One Meridian Plaza fire happened in Philly, and that showed a need for some kind of lit signage that allows firefighters and first responders to make their way through the structure and understand where their location is in the building in reference to where they started out or where the exit is, so that they can find their way out of those kinds of situations in an emergency. And in the World Trade Center, there was if you remember back long before 2001, there was a bombing in the basement of the World Trade Center, and that sparked some interest in trying to find out ways to expedite getting people out of high-rise buildings. Of course, those are extremely high-rise structures there, and so some things were put in place that actually did benefit in the September 11th tragedy that happened later on. Well, that 93 bombing that happened in the World Trade Center sparked some research to try to find out ways to improve building structures. And so the New York folks got in contact with the Canadian Research Council, and they did some surveys, and they did some prior to 9/11, which led to some markings that happened in the towers there that actually was beneficial. And then after 9/11, they did another research to confirm and fine tune some of their findings in 2007. But effectively, here's what happened. The research group worked in a firefighting rescue training tower. It was a few stories high, and they brought in a lot of people to navigate this structure in different environments. And one of the environments was just normally lit with, how you would normally light up a stairwell, just regular light. And then they marked the stairs in the darkness in 3 different ways. One with a really powerful, thick, heavy-duty bunch of markings. One with markings that were just on the stair edges, these little L shapes, so that the center part of the stairs were still dark, but the edges were marked. And then in the bottom left, they made a very consistent set of markings that were 1 inch wide, consistent throughout the stair markings, the handrails, the navigation through the landings, signage, and things of that nature. And what they found out is when they ran through all of these, they timed people going through this stairwell training tower to see how long it took them to get through there. And what they figured out was that the 2 on the left, the regular lit stairwell, just like you're going through a normal lighting, and the consistently lit 1 inch, which would be details C and E that you're looking at there on the left side, had effectively the same amount of time for escape. So a person could escape with a properly lit stairwell in the same amount of time they could with the one that just had perfect lighting. And then the 2 on the right were slower. The one on the bottom right was overwhelming. It just had too many markings, and it just startled people, and it sort of caused pauses. And the top right, the L-shaped markings left the center part of the steps where they were not visible, and it slowed people down getting down there. And the more people they had, it turned out to be worse, because when people blocked the L shapes on the edges, then you couldn't see the center steps at all. So they paused making their way down the stairwell. So the code became the one on the bottom left, which was the 1 inch markings. And so that's why the IBC and IFC and everybody else adopted. That was the winner. So not long after that, the building code folks did some interviews with some of the folks that survived the 9/11 incident there, And they found out that these photoluminescent markings were part of what really helped people make their way out of those structures, along with people helping them out and first responders as well. So then the process became, okay, we know what to do now. How do we do it? How do we get this throughout the industry? And so different pigments were used, and some were found to be very, very strong, good absorbers of light, and good at rebounding that light back out and then glow in the dark. And then they said, okay, well, what do we put it on? Well, you can put it on metals, you can make it out of plastics, you can make tape out of it, and you can do paints and coatings. And so there's different kinds of applications that you would use these different sorts of delivery mechanisms. We're going to talk about codes and how that relates to all this, and we're going to mainly focus on the International Building Code that sort of drives the whole picture for the fire code and all that as well, and then the NFPA. And the reason why we picked those two is because the International Building Code really drives all of the code work for new structures, and the NFPA is generally the rule book that is used for renovation to existing structures. So IBC's new stuff, NFPA is updates to existing kinds of buildings. What kinds of buildings use this? Well, tall buildings and different kinds of assemblies. Mostly they're high occupancy type structures, with the exception of like apartment buildings. So it's transient populations where people don't live in this place. They're in and out of that all the time, but it's frequently, visited, and so it needs some kind of process for people to find their way out in an unfamiliar environment. Things like any large gathering kind of a place, like religious gathering places, casinos, arenas, theaters, schools of all types, hospitals and healthcare, retail stores, office buildings, all those kinds of things meet that sort of criteria. Like, these are the buildings that need these kinds of markings, and those are in IBC 1023.9 and 1025. We're going to concentrate on those two areas. So what is a high-rise building? Well, according to IBC and International Fire Code Section 202, anything with occupied space above 70 feet. And that can now include a roof line. So if you have an occupied roof, like they have a rooftop bar or something like that, then if it's above 75 feet, then that is where the requirement comes in, because a fire truck ladder can only reach 70 feet, and that's the maximum height, and that's the reasoning behind why they chose 75 feet. So you don't just mark from 75 feet up to the top of the building, though. You have to go all the way to the base of the building and go all the way up. So you don't just do partial markings. You mark the whole height, but the mechanism is above 70 feet. Now, there are kind of two major categories here. One is there's a particular type of signage called floor identification signage. We'll show you some good images of that, but that is required from 3 stories and higher. So that's the one that came out of the fire, where the firefighters, couldn't locate or couldn't find their way throughout the structures there in the Philly structure. But the markings on the stairwells, handrails, and all that sort of thing like that, those are all required for 75 feet or taller occupied space. And there are some other rules in there. So the 1025 set tells you got to mark the steps, landings, handrails, any kind of demarcation, obstacle markings, door markings, handles, all that sort of thing are all identified in there very clearly. But it also states that it must be uniformly marked. I talked about the way the testing was done in the research facility, is that they found out that the uniformity, that all those consistent 1-inch markings really helped people navigate their way out of the structure. So there's a uniformity clause in there that kind of keeps that in place, so that that's part of the code. And then there's a minimum amount of light that it takes to charge one of these particles. And so that's also part of the standard. So you'll see some examples of it. But just generally speaking, when the lights are on, this is what you see. All those kind of yellow looking strips that go around the landing and go across the steps, go down the handrails, the signage that you see, the door markings that you see, that's what it looks like when the lights are on. And when you enter this in an emergency situation and there's no lighting in there, your pathway is intuitive, because you have all of these glow in the dark markings that all you have to do is just follow that path all the way out throughout the structure. And so that's the ideal scenario for getting folks out and getting first responders in. So it goes both directions. First responders can find their way in the dark upwards to get people out, and people can find their way out of the structure in the dark by looking at the markings on the way down. So this is the sign that I was talking about. This is the One Meridian Tower project. This is what brought this up as to be part of the code. And so there needs to be an identifier that says, where are you in this structure? And of course, for firefighters, they're trying to communicate with other firefighters and their communication crews to know where to go if they're trying to help folks escape out of a structure. So there's a lot of information on this sign. And so the one is you have to identify, what stairwell or what ramp you're in. Are you in the north stair or in the south stair or the east or whatever, or stairwell one or whatever you call it. Is there roof access? So because a lot of times there's helicopters and things like that where they can take people out from the roof area. So you need to know that. What floor are you on, right? And that is a raised character. So you can feel that. If there's a number 4 or 5 or whatever, you can feel that. And there's also braille underneath that. So there's you can feel that's got the braille number of the number sign and braille for the number of the floor. It tells you if you terminate at the bottom or the top. Do you got to go up or down to get out of this? And how many levels do you need to go in all? And the sign has to be placed 5 feet above the floor line, and it has to be placed in an area that if the door is open to exit, that it doesn't cover up the sign. So you got to make sure that it's away from the hinge side of the door so the hinge can't close off and block the sign so people can't see it if the door happens to be left open. So a lot of rules to that, and it's a big sign, 12-inch by 18-inch sign. But that's the section 1023. The rest of what we'll talk about is going to be in section 1025 of the IBC code. There's a lot of rules about the placement of all these markings. Generally speaking, you place anything on the step, the part where you're walking up and down the steps, the globe portion needs to be within a half an inch of the edge of the step. They don't want it too far back or hanging over or anything like that, because that can cause you to put your foot in the wrong place. So they want it to be right there on the edge of the step. There can't be larger than a 2-inch break. There's some allowances. You'll see a 4-inch number that happens frequently, and that is used because it is determined that up to a 4-inch gap in between the characters, people can mentally make the leap on their own. So if there's a change in direction, like on a handrail, or a change in direction, or a height above or below a floor marking or something of that nature, then those are all within the bounds of people can see that and make up that difference in their mind. So it's very important to have durable functional material in there, especially on the steps themselves where the people's footfall is going to happen, where everybody's going up and down. So the edge of the stair is quite a critical element. So it's very good to have slip-resistant materials that are very durable, flexible. They won't crack when there's a lot of load being applied to the stairs, like a lot of people going up and down the stairs with the stairs deflecting up and down. You don't want things that are going to crack and break out. So if you have epoxies, they need to be flexible and things like that. And then the strip has to be, the same width as the handrails and the markings and all that, which is generally 1 inch wide. The stair steps themselves are addressed in the 1025.2.1 and 2.2 for the steps and the landings. And there's different kinds of steps that can be applied. There's different types of stair nosings that can be applied to the steps of the stairs. So they can be cast into wet concrete when the construction is being poured in place, or it can be attached to the edge of the step on the surface by screwing it down or gluing it down, or any number of different kinds of combinations. All of those are acceptable as long as they meet all the other criteria for a typical stair nosing. One of those criteria is the ADA for the edge height. So if you're walking across the surface, you can't have more than a 1/4 inch square edge for people to step on. Otherwise, it has to have an eased or beveled type edge. Also has to meet a certain slip resistance so that it has a static coefficient of friction, either wet or dry, that is adequate or better than adequate for people walking across these stair nosings. So they have to have an abrasive quality to them that meets a 0.5 or a 0.6 or greater number there to make sure that whatever you're stepping on doesn't allow your foot to slip. So that's a pretty typical set of stairs. There's different ones there that you're looking at. And so that's a very eased edge. You can see where the foot is falling on the stair tread. There's a glow within a half an inch of the edge of the step. And that it's got a very eased edge and it's very slight. And, so it's comfortable to walk across when you're doing egress in or out of the stairs. Handrails are section 1025.2.3. They are required to be a 1 inch wide marking on the top of the handrail. They're curved with the handrail. You can use tape, you can use plastic extrusions, you can use metal strips that have been preformed to this kind of a shape. And you see that 4-inch dimension there where it changes direction, either horizontally to vertically or in a 90-degree. You can have up to a 4-inch gap. So you're not having to make a bunch of miters and things like that as you're marking these stairwells, but people can easily see and make that. It's pretty clear that that's easy to follow that path. Very intuitive. That's the main thing. It's got to be a very intuitive path for folks. When you get into the landing areas, so the perimeter of the steps and things like that, you can put markings directly on the floor, or you can put them on the wall, but no more than 4 inches above the floor. And so it's a good example of what those kind of markings look like. So when you're going through and changing directions on stairs to go from level to level or mid-level or whatever that is, you want that path to be continuous. You want to see the rails go marked. You want to see the steps get marked. You want to hit that landing and be able to visually see, oh, I've got to change direction here, make my way on down the area there. And one of the things that's important about that is the exit door level has a particular kind of marking because they want you to obviously see how that goes. But these are mid-levels. So this could be floor 2, 3, 4, 5, 25, whatever it is there. In the dark, they do not want you as a pedestrian exiting to try to go into a door to feel safe, because you never know in an emergency where the harm is. So the fire could be right behind that door, and you could be opening up something into a very dangerous situation. So the way this is handled is the demarcation markings that go around the landing actually go right across the door, either in the floor in front of it or right across the base of the door. So in the dark, when you're leaving, you don't really see a door. You just see a pathway that says you got to keep going down, you got to keep going down, you got to keep going down to get out of the structure. So that's very intentional. Also, something that's very intentional is any obstructions that protrude more than 4 inches out into the landing area are supposed to be marked with obstruction markings. And so these are very specific striped, alternate stripes, black and photoluminescent markings that provide you with a visual automatic caution. As soon as you see that striping, you know that that's something I don't want anything to do with. I want to make sure I avoid that. And they also mark the flooring and things like that to make you want to avoid that area. In the dark, you see almost nothing except those black stripes and a path that says don't go in behind that. One of the things they want to make sure of too, though, when they make these markings is that they don't put the markings on top of things like handles or valves or something that needs to be read. So it's very clear language in there saying, put your obstacle markings on there, but don't make it to where whatever you're marking is not functional. So these are a lot of good examples of different kinds of markings. There's hose cabinets, right? Pipes, electrical, the different kinds of uses that are required by the fire department and the water department and things like that for sprinkler systems and all those sorts of things in these stairwells. So to make sure that you don't bump into that sort of thing, get injured or break it or whatever else in the process of trying to egress the structure. So the final exit door is where you have to make sure you change the path that you've had with the other previously marked doors that were on the interim floors. This door, you want to make very clear that this is the exit. And so the rule is that you need to mark the final exit door or any other door that is required for you to go through to get to the final exit door. So sometimes there's a small corridor and you have to go through 2 sets of doors to get out of the structure. When you mark these, the way you mark them is that you run your demarcation markings across the floor or across the wall, no more than 4 inches above the floor, and then you completely wrap the perimeter of the door. So you wrap the jambs in the head of the door, and you do not mark anything across the bottom of this door. So it becomes very obvious in the dark that this is an opening. And then that door is also marked at the handles, whether it's a push bar or a doorknob or whatever. And there's an exit sign that goes on the base of that, no more than 18 inches above the floor. So the exit sign that you see on the top of that door is a standard exit sign. That's really not part of the egress stairwell marking. That's a different set of criteria. The reason why you have this no more than 18 inches is because if it's a smoke-filled area, then you should be able to see this even if you're on the floor crawling on your knees and trying to work your way out of the structure. You can still see that this is obviously the path to go through to exit this opening. So this is a properly marked double fire exit door. So you can see that the whole perimeter of the door is marked on the jambs in the head. Both of the bars that you have to push to get out are marked with a push to open sign, and that there are exit markings on the base of the door that says this is the exit. And those have requirements for the sizes. We'll go over those as well. There's a little running man symbol, so that's universal. And in this case here, there's also an arrow, which is not required. But the requirement for marking a door handle or push bar is that you have to have 16 square inches. So that can be a 4-inch by 4-inch placard. It can be any shape that makes up 16 inches. So if it happens to be a push bar or something like that, then you can have something that is, makes up 16 inches, maybe 2 inches wide by, whatever, 8 inches long or whatever else it is required for that to fit onto that mechanism that opens that structure, that door. The sign that's on the bottom of the door, the requirement is 4-inch tall letters, the word exit all in capital letters on a sign, the base of the door, no more than 18 inches above the floor, or you can have a running man symbol. The most common that is used is both. It's a sign that says exit and it has a running man on it. That's the most common way. So that's what you see in the red box on the lower left. That's why most of the doors are marked. People ask about, well, why don't you just put a sign on the doors that say, the interim doors not to exit? Well, the intention is the way they're marked with the flooring going across the base of the door is that's completely blacked out and no one even sees a door. You can put not an exit signs on the doors. It just tells people there's a door there. And so it could, even though it says not an exit, people might still want to use that. Like, well, okay, there's a door there, so maybe I'll try that or something like that. When people are panicked, there's a lot of different decisions that are made without forethought, some in just desperation. So anyway, we want to make sure that this path is clearly marked in the way that the code intends. And so I mentioned to you about the uniformity. The 1025.3 of the IBC has a uniformity clause, which says everything should be marked the same way. It should have the same kinds of sizes of markings, the same edge-to-edge markings, things of that nature. So people are not confused. You don't have different sizes of glow markings, which could cause someone to pause and say, okay, why is that extra bright and why is this not? And why is that extra wide? And am I supposed to do something? This just keep it all uniform, makes it intuitive. There are a couple of test standards that are referred to from the building code. So section 1025.4 of the IBC code references how the performance is supposed to work for these glow-in-the-dark egress marking materials. And one is Underwriters Laboratories UL 1994, and the other is the American Societies of Testing Materials E2072. Both have requirements on how much light charging. Generally speaking, it's 1-foot candle of light for an hour will charge to give it enough bounce back of light of 30 millicandelas per square meter for 10 minutes, and then 5 millicandelas up to an hour and a half. So you should have a visible light. If you have an hour's worth of charge on a minimal amount of light, you should have a substantial charge for the first 10 minutes and a very visible charge for the next hour and a half on the way out. And the majority of these photoluminescent markings that I have seen last many hours afterwards. They get a little bit more faint over time, but they'll last several hours. So people ask about paint and tape and things like that. And these products all have their place. But one thing that Underwriters Laboratories has stated in a document related to this is field applied paint. So as opposed to factory applied paint. So factory applied paint would be a paint that is applied to a material that would be brought out to the site and then attached. So tape or extrusions or metal on paint on metal or whatever those kinds of things are. But factory applying paint directly in the field is not something that is recommended by Underwriters Laboratories, because they say you can't get the consistency. What they have seen in their statement is that you can't get the consistency. And so what happens is if you have inconsistency in the pigmentation in the paint, it looks like splotches. And when you have splotches on a step in the dark and the lights go out, it looks like holes. It looks like dark spots look like either holes or broken, and it causes people to pause, and that's what they don't want. They want people to continue going through. But one application that is pretty good for field applied paint, because hardly anything else works, is a metal diamond tread stair like you see in that middle picture there. It's pretty hard to put anything on there that holds up. So field applied paint is probably the best alternative in those kinds of situations. So exit enclosures where photoluminescent markings are installed shall be provided not less than 1-foot candle, right? This is what I was saying was the standard there. So what this means is, though, any building that is going to be occupied has to have the lights on an hour before any occupants come into the building. So if you have a 24-hour building, you have 24-hour lighting. If you have a building that opens up at 8 o'clock in the morning, the lights need to come on in that stairwell at 7 o'clock in the morning. And it requires that because that allows these pigments to be charged fully by the time the building is occupied. And once the building is occupied, then if the lights go out in an emergency, then they're fully charged. If they don't have an hour to get prepped ahead of time, then there's a period of time that they would not be completely effective. And so that's the rule. You got to have it on, lights on an hour before occupancy. And so the test standards, ASTM E2072 and 2073 are used along with UL 1994 to state these same kinds of things, that the timing is critical for charging and all that, so that you have the kind of result that you need when the lights go out. So it's a very good example of what happens with the lights on and the lights back off again. So that's what you want to see. A lot of other notable codes are cities and municipalities. There's, as I mentioned, the NFPA, which is usually governed for existing buildings that are being renovated. OSHA has standards. They have a general duty clause that says if the building doesn't happen to be one of those in that long list of high occupancy type buildings that I stated earlier, but if someone is paid to go to work in that building, then they should have the same kinds of protections under the code that any other building would have. So let's say you've got, say, residential apartments or condos are not part of the standard list. However, you have someone who works the front desk or someone who does maintenance or whatever it is. If that person is required to be in that building, they're paid to be in that building, then they are required to have the same kinds of protections. So you would have to have the same kinds of markings in that structure because you have someone in there in that situation that is not just transient or not just permanent resident population, but would be a worker or some type of transient population. So here's a few good examples of different structures. Here's a high-rise building with markings in it. This is Time Warner Center in Manhattan in New York City, so properly marked, right? Parking garage. This is John Wayne Airport parking structure. So you might not think, well, why? It's kind of open air, but it does get dark and lights go out and you need to find your way out. And some of these structures are quite large and some of these are retrofit. So if they're being retrofit, it can be 3 or 4 stories. It doesn't have to be 7 stories to qualify. And you can put these in any kind of structure, where you've got some kind of an egress stairwell. So a parking garage is another one. Arenas, the Barclays Center in Brooklyn, New York. Another good example. This one has got a lot of markings, multiple stairs going opposite directions. You can just imagine trying to get 60, 80,000 people out of a structure during an emergency with no lighting, right? So that'd be really, really tough. So it's another good example of markings in there. So they can get quite complex. Outdoors, you think, well, why would you need them outdoors? Well, certain areas like this particular one, San Antonio River Walk, there's a lot of walking across that river back and forth on little bridges. And again, there's a lot of lighting out there. But if the lights go out and it's totally dark, you don't want people falling in the river. This allows people to make their way across all those openings and all those stairwells and things of that nature and bridges. Healthcare centers is the Hennepin Healthcare Center in Minneapolis, Minnesota. Another really good example of an egress stairwell. They're on the outside edges of the structure. You can see that big rotund area on the front, and right there on that kind of you see sort of an L-shaped segment right there. There's egress stairs that are lit by sunlight, but when it's dark, there's no sunlight. So these things glow in the dark when all the lights are out. And of course, in an emergency, if the lighting went down, you'd be able to find your way out of that structure as well. Stadiums, stair nosings are great for slip resistance. There's a CenturyLink field in Seattle, Washington. This area is called the Crow's Nest. They had people slipping and falling. They decided to put some stair nosings in there. During the discussion, they said, you know what? Sometimes the lights go out, like in the Super Bowl that happened years later after this was put in. The Super Bowl, the lights went out and it was completely dark. And if they had had these kind of stairwell markings, that whole place would have been lit up at every stair and you could have found your way out of that structure completely in the dark. But anyway, this provided all of that kind of protection. And so that wraps it up. That'll take us to the questions. Here's some good references for you. You can look up the 2024 International Building Code. You can look at that research report, the National Research of Council of Canada, the New York City, which is really where all this kind of got started. Their local law 26, and then also their report on the World Trade Center. trying to get 60, 80,000 people out of a structure during an emergency with no lighting, right? So that'd be really, really tough. So it's another good example of markings in there. So they can get quite complex. Outdoors, you think, well, why would you need them outdoors? Well, certain areas like this particular one, San Antonio River Walk, there's a lot of walking across that river back and forth on little bridges. And again, there's a lot of lighting out there. But if the lights go out and it's totally dark, you don't want people falling in the river. This allows people to make their way across all those openings and all those stairwells and things of that nature and bridges. Healthcare centers is the Hennepin Healthcare Center in Minneapolis, Minnesota. Another really good example of an egress stairwell. They're on the outside edges of the structure. You can see that big rotund area on the front, and right there on that kind of you see sort of an L-shaped segment right there. There's egress stairs that are lit by sunlight, but when it's dark, there's no sunlight. So these things glow in the dark when all the lights are out. And of course, in an emergency, if the lighting went down, you'd be able to find your way out of that structure as well. Stadiums, stair nosings are great for slip resistance. There's a CenturyLink field in Seattle, Washington. This area is called the Crow's Nest. They had people slipping and falling. They decided to put some stair nosings in there. During the discussion, they said, you know what? Sometimes the lights go out, like in the Super Bowl that happened years later after this was put in. The Super Bowl, the lights went out and it was completely dark. And if they had had these kind of stairwell markings, that whole place would have been lit up at every stair, and you could have found your way out of that structure completely in the dark. But anyway, this provided all of that kind of protection. And so that wraps it up. That'll take us to the questions. Here's some good references for you. You can look up the 2024 International Building Code. You can look at that research report to the National Research of Council of Canada, the New York City, which is really where all this kind of got started. Their local law 26, and then also their report on the World Trade Center.
This concludes our AIA Continuing Education On-Demand presentation. On behalf of Balco and the EBS Group, thank you for your time and attention. To receive credit for this course, you'll need to complete a 10-question quiz. Simply click the test button below to get started. A passing score of 70% or higher is required. If needed, you can retake the quiz as many times as necessary to achieve a passing score. Once you pass, your AIA Certificate of Completion will be emailed to the address you provided before taking the quiz. If you're an AIA member, we'll submit your credit directly to AIA on your behalf. Please allow up to 10 business days for your credit to appear on your AIA transcript. The EBS Group offers AIA-approved courses on life safety products. Balco covers expansion joints, photoluminescent egress systems, and fire stopping. Smoke Guard focuses on fire and smoke protection solutions. And Greco offers courses on commercial architectural railings and code compliance. Scan the QR codes or visit their websites to explore all available courses. If you have any questions or would like more information on Balco, visit our website at www.balcousa.com. Thank you again for your time and interest.